Generative AI, machine learning, deep learning. You hear these words everywhere these days. But I'm here to cut to the chase and explain these concepts to you in simple analogies, simple explanation, real world examples, and also some simple demos you can try yourself. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills and also become more productive using AI powered tools and workflows. AI is basically the science and engineering of making machines and computers do things that normally would require human intelligence, but all on their own. This could be anything from recognizing speech and images to problem solving and making decisions. Think of AI as a Swiss Army knife. It's a collection of tools that together makes computers do smart things. Some AI tools and systems are very simple and rule-based, while others can be pretty sophisticated. Here's a real-world example, Google Maps. Did you know that they use AI to study and understand traffic patterns and then predict when the traffic jams are going to happen? But also, it's not just based on a ton of live data, but also external factors like accidents, road closures. So, all of that together, they figure out what's the fastest way you can get to your destination. Let's try out a very simple example. On your iPhone, pick up and you can then enable Siri and you can ask it, "Hey Siri, can you tell me what is the weather in Austin?" That's where I live today. And as you can see, it showed me that right now in Austin it's 96 degrees, very hot. So as you can see, Siri and the AI can hear what your voice, understand what it's saying, interpret it, and then go fetch the data, in this case for weather, and also display it to you or read it back to you. So this is the power of AI, but this is very simple. So we're gonna get to the more complicated ones next. If you have enjoyed this video so far, I would really appreciate it if you hit that like button, but also comment and share. And if you haven't subscribed already to my channel, please go ahead and do that. I would really appreciate it. So I wanted to share a few pictures of my trip this past weekend. I went to a safari tour in Texas. So here are some pictures and small clips that I took. Let's dive deeper into one of the key areas of AI called machine learning, or short for ML. It is basically you teaching the computer to find, analyze, and find patterns by giving it a ton of data. And it's not like you're just going and programming every rule like you do with Siri. It's a smart AI. You can think of it as teaching your dog a trick. When you do that, you make your dog to repeat the same behavior and also correcting it and giving it feedback until it masters it. You don't just give your dog a bunch of manual of rules and hope that it learns the trick, right? So it's the same thing here. The more data you feed into an ML model or algorithm, the better it gets. Here's a practical example. Your email spam folder. That's right. So the way it works is this ML in continuously analyzing and learning from a million different emails that are marked as junk. And therefore, it's getting better and better at identifying and predicting what emails that you're receiving are spam. And that's how it keeps your inbox clean. Here's a simple way you can try out machine learning all on your own with Google's Teachable Machine. It does not require any programming. So here's how you can do that. Go to teachablemachine.withgoogle.com in your browser. Select Get Started and choose Image Project. Next, upload or capture images for two different categories, like a pen and a cup. Then train the model by feeding it examples for each category. Lastly, test it by showing an object to your camera and watch how the model guesses what it is. Let's dive into deep learning, short for DL. It is a branch of machine learning, but with some serious power. You can think of machine learning as teaching a pet, a dog, a trick, and DL, deep learning, like training a team of expert detectives who work together to solve complex problems. I mean, technically, you could also train a bunch of German shepherds and send them off to war, right? So it's same thing. But anyways, so yeah, it has deep learning has layers of algorithms that actually mimic and model the way human brain works. You can think of it as the earlier layers could recognize patterns like shapes, like shape of a circle or rectangle. And then the deeper layers really recognize the more complex patterns, like instead of a rectangle, they recognize that this is a face. And also they can figure out what kind of emotion that face has, like happy, sad. Here's a real world example. Social media apps, for example, Facebook. You know how when you go on a picture and you're trying to tag your friends on that picture, and Facebook automatically says, "Oh, this face belongs to so and so." Yeah, that is all because of deep learning. It's been trained on millions of different faces, and now it can recognize, analyze, and predict whose face that is you're trying to tag. Here is one way where you can try out deep learning for yourself using TensorFlow's Playground. It is a free, interactive website, no coding involved, that you can try. Let's go over an example. Visit playground.tensorflow.org on your device. You can then go to set the problem type to classification. Next, you can increase the number of hidden layers by clicking the plus icon. Next, I would recommend click on that play and observe how the model's ability to separate complex data improves with more layers. Tweak the setting, play around with it to get a hands on feel for how deep neural networks, also known as deep learning, builds understanding step by step. And now we get to the very exciting and popular part of AI, generative AI. Basically, ChatGPT. So yeah, that's it. Bye. I'm kidding. Okay. Generative AI doesn't just analyze the data and make predictions like your old school AI or deep learning and machine learning does. It goes one step further and it creates new content inspired by what it has learned. You can think of it as a inventive chef that has tasted 1,000 or million different recipes and now is inspired and creating its own brand new recipes and dishes. Generative AI learns from a huge data set of data, images, voices, music, anything you can think of. And then based off of that, creates these fresh new content for you. An example of this is basically ChatGPT, which you can talk and ask it anything. It responds to you really quickly. And so that's text based, and Dolly within ChatGPT to create images, like brand new images, some of those that have gone viral. And also Sora, newly in ChatGPT, which generates videos, right? Brand new. You give it a prompt. Although I think it needs some improvement. I haven't been able to successfully use it, but maybe because I haven't worked in the movie industry field. Who knows? And as you can tell, there are like a lot of other ones out there today, and they're all different and expert and good in for specific tasks and areas. Like Perplexity could be really good if you're doing research. Claude and Anthropic could be really good for writing code. ChatGPT really is good in that conversational. Everyone talks about ChatGPT these days, but let's be real. They either go too much into the technical details or they just kind of brush it off like it's autocomplete on steroids. But in this video, we're going to go deeper to the right level. And by the end, you're going to be able to walk away with a mental model that sticks, filled with analogies, real world examples, research references, and practical takeaways. So stick around. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills and become more productive by using AI powered tools and workflows. Okay, but first, what is an LLM, large language model? It is basically a system that predicts the next word and so on, token by token. And that's it. And we'll explain what tokens are in a little bit. Imagine when you train such a model on terabytes of text and billions of parameters, guess what happens? It becomes intelligent and fancy. Andrea Carpati, the former founding member of OpenAI and former director of AI in Tesla, said this about LLMs: compression engine for the internet. basically taking messy human knowledge, compressing it into probabilities, then replaying it back when you prompt it so. OpenAI has a term for ChatGPT, stochastic parrot. It was a term that was popularized by Emily Bender and also Timnit Gebru's research paper, which basically means that a model repeats back its learned patterns without really understanding it, just like a parrot. But here's a powerful part. I don't know if you've ever used the Gmail's Compose Smart feature. Yeah, so that's like a baby ChatGPT, and ChatGPT, as we know it today, is basically its cousin. Let's do a quick demo. I'm going to quick open ChatGPT and let's type in a fragment phrase like in software engineering, technical debt is like, and let's see what happens. Wow, so ChatGPT completes it with an analogy. This basically shows the predictive power of ChatGPT at scale. If you've liked my videos so far, I would really appreciate it if you like, comment, share, and also if you haven't subscribed already, please hit that subscribe button. It really helps the channel to grow, but also to show this content to others who might find it useful. I will be forever grateful to you, but also I will respond to all of your comments as soon as I can. I promise. And here's a cute little video that I generated by AI for you. All right, let's continue, shall we? Oh, wait, as usual, please wait until the end because I have a joke for you. Let's go ahead and explain how the LLMs work under the hood. The first step is basically they take text, words, numbers, and break them down into smaller pieces, like Lego bricks. In this case, we call them tokens. It's basically like an example would be taking artificial intelligence, the phrase, and we would break it down into 4 different tokens. This helps LLMs be a system that is very flexible across different languages and code. Next, we're going to do a demo on Hugging Face, and I'm going to show you an example of how LLMs break things down into tokens. Open your browser and go to huggingface.co/tokenizer. In the input box, let's go ahead and type in a simple sentence. And artificial intelligence is amazing. Let's look closely. See how the sentence is split into fragments called tokens? Art, official, intelligence. Demonstrate and have the tokenizer handles subword units. After the tokenization process is completed, here's where the real deal happens. In 2017, Vaswani and colleagues wrote a paper called Attention is All You Need, which basically was the foundation for transformer architecture. Attention is basically always put on the spotlight by the model. It doesn't just look at the last word that you typed in your sentence in ChatGPT, for example. It really looks and weighs which words of that you've written matter the most. And it puts the spotlight, that its attention on those words. The third step is basically the layering. Imagine if you have 100 different interns looking at the sentence you're giving the model from a different angle. Some look at the verb you used, some look at the tone, some look at the syntax. And then all these interns, they pass around to each other the notes they've taken on your sentence, which is basically called multi-head attention. Okay, so we went from tokenizing to putting attention of spotlight on the most important words to using layers to look at the sentence from different perspectives. And now we are at the last step, which is called probability engine. It's basically these models don't just pull something and give that to you from their memory. No. So they, based on the context, so like whatever's already been written so far for that sentence, they take that context and generate top 5 probable next words. And then they pick one and then move on to generating the next word, and it goes on and on. That is why these models, LLMs like ChatGPT, can write essays, can write code or poems. Try a prompt like the cat sat on the, and kind of watch like how the model ranks different options and picks them based on probability. Things like on the mat or floor or couch. Actually, Hugging Face has a really nice visualization tool that we're going to try next. Let's go ahead and go to the Hugging Face website and enter the sentence, basically your prompt. We were using earlier, the cat sat on the. All right, as you can see, the tool should display the next possible tokens, words or subwords, along with their probability scores. Some tools present this as a heat map also, or bar chart, or list. Now, the so what? How do we actually use this power at work? Well, the first thing you want to do is think and act like a prompt engineer. When you're giving your prompt to LLMs like ChatGPT, make sure that you're specific and clear on the task, give any context that you have, any constraint, and also like the output format that you wanted to give you the answer. Here's an example. Write a Python function that parses a JSON file and logs errors with timestamps. Return code only in a fenced block. As Ethan Mollick puts it, prompting is basically the new most important management skill. You basically treat LLM, the model, as your teammate. Well, more like a junior level teammate. So you always have to review its work. It's like when you're using Copilot that it writes codes for you, you act like the PR reviewer. You gotta, code that, review that code. The other thing you can do is if you have a big ask from the model, it's always good to break it down into smaller tasks and then take the output from one task and feed it into and add to it. Basically, daisy chain your until you get to what you want. Here's an example. Summarize this legacy function. Then take that output and put suggest test cases. Then write the test cases. And then at the end, once you've picked all of your cases, test cases, you can be like, generate a test runner. This basically reduces the amount of risk. And lastly, remember to be skeptical of the response and output that you get. It is known that LLMs basically hallucinate sometimes. It is getting better, but even Sam Altman said that you should treat them as high variance interns. So always check your work, especially for very critical and important tasks. ChatGPT didn't get smart from reading the internet. That's the lie everyone believes. The truth? 3 secret steps. And the third step, most AI engineers don't even know that exists. You're about to learn the hidden 3-step pipeline that turns garbage into ChatGPT, the billion-dollar technique that made AI actually useful, and the new method that's about to make RLHF obsolete. I'm Edna. I've been in tech for over a decade. I've gone through promotions, a layoff, and burnout that changed how I see work. Now, I help software professionals grow and work smarter with AI. So subscribe and let's level up together. And as a thank you, here is a picture of my dog, Caden. Quick question, which LLM do you use? ChatGPT, Claude, or Gemini? Comment below C, A, or G. No judgment here. Just curious to see whose team what. Here's what no one tells you about LLM training. Companies scrape trillions of words. It's in books, code, Reddit arguments on whether hot dogs are sandwiches or not. They feed all of them to a neural network. That is called pre-training. And it creates something completely useless. I'm serious. Why? Because pre-training only teaches one thing. Predict the next word. Not to be helpful, not to follow instructions, but kind of autocomplete on steroids. It's like memorizing every single cookbook out there, and yet you have no idea how to make a simple dinner. Pre-trained models are brilliant idiots. They know everything, but they understand nothing. So, how do you fix that? How do you turn this chaos into ChatGPT? That's where the real training begins. 3 steps, but each more critical than the last. Stick around because in 3 minutes, I'm going to show you the code that proves how one technique changed everything. And hit that like button if you're ready to understand why. Step 1, supervised fine tuning, SFT. This is where the humans intervene. OpenAI hires contractors, freelancers, PhD students, and they go off and write thousands of perfect examples. Here is an example. Prompt: explain quantum computing to a 5-year-old. Response: a clear, simple explanation. Another example, prompt: write Python to reverse a string. Response: clean, commented code. Then the model goes off and trains on these. It learns how to imitate good behavior, how to follow instructions, how to respond, not just autocomplete. And it works. After SFT, your model can write code, hold a conversation, and answer your questions. But here's the catch. SFT teaches only one way to respond. The way that contractors wrote those examples, no flexibility. If you want a more concise answer, well, good luck if the train was on a lengthy answer. If you want humor, you might only get the very serious tone. What if you wanted to adapt to your style? Can't do that either. It's a chef who can cook 5 perfect meals, but only those fives, nothing else. So the companies did something radical. RLHF, reinforcement learning from human feedback. And this is the secret. This is why ChatGPT went viral. Here's the genius move. Instead of teaching the model what to say, it teaches the model what humans prefer. Here's the process. Step 1, generate 4 different responses to the same question. Step 2, humans rank them, best to worst. Step 3, train a new AI model to predict the human preference. Step 4, here's the fun part. It runs the reinforcement learning. So the main model generates responses. The reward model goes and scores them. So in return, the main model is chasing how to get those higher scores. And then this runs in iterations on millions and millions of preference judgments. And suddenly everything changes. And then the model doesn't follow the instructions anymore. It optimizes itself for helpfulness, for safety, for sounding natural, for responding to your questions with what you meant, not what you asked. There is a line from OpenAI's paper that is insane. Our 1.3 billion parameter model with RLHF outperformed our 175 billion parameter model without it. Pause. Go back and read that again. A model which is 100 times smaller beat the massive one just by learning preferences. But RLHF has a dirty secret. It's expensive. Companies were burning millions of dollars on this. And then somebody asked the obvious question, what if we skip the expensive part? All right, we are on third step. In 2023, Stanford drops a paper, DPO, Direct Preference Optimization. What if you don't need to train a reward model at all? You can just skip it. The DPO says, train the model directly on preference pairs, no middleman, no separate reward AI, no complex RL loop. You're gonna still have humans rank the outputs, but instead of building that huge expensive pipeline, the DPO just tweaks the main model to follow the preference of which likely answer and outcome is more preferred than the other. Anthropic is using it for their Claude models. Meta is using it for their Llama models, so it's becoming pretty popular. So understanding these training pipelines changes how you use these models. Model that went through heavy SFT on code, it loves structure. Give it structure. A model trained with RLHF, it is optimized for conversation. So prompted conversationally. Model that uses DPO, it's optimized to follow preference patterns. So use that to your advantage. Let me show you how. Most people won't see this. This is actually how billion-dollar companies do it. So watch closely. Here's DPO in code, pure Python, no fluff. Transformers library are TRL for DPO, Torch backend, done. Loading GPT-2. Yes, it's small and it's free, but it's perfect for demos. Here's the key, preference, pairs, same prompt, 2 responses, one humans chose and one that they rejected. So here we're gonna explain recursion simply. Good answer versus garbage answer. This is what DPO trains on, human preferences, raw and direct. Initialize the trainer, beta controls optimization strength, higher beta, stronger preference alignment, but risk overfitting. We're at 0.1, conservative, smart. So run training, in reality, this goes for hours on GPUs, but conceptually, dead simple. Model sees the prompt, sees which response won, adjusts weights to make winning responses more likely. That's it. That's modern AI alignment. No reward model, no complex RL, just direct optimization. And it works. If you like this video, I would really appreciate it if you hit that like button, comment, and share it with a friend. Also, subscribe if you haven't already, so that you won't miss out. Just before I let you go, I have a full-on YouTube video on RAG. So go ahead and watch that next. See you next time. Ever wondered how Spotify knows exactly what you want to hear, or how Zillow predicts your house's price before you even post it? It's not magic, it's machine learning. And in this video, I am going to explain to you not just what machine learning is, but how you can exactly build it on your own. So let's dive in. Hi, I'm Edna. Welcome to my channel. I help other software professionals grow their skills and become more productive by using AI-powered tools and workflows. Let's start with supervised machine learning. Supervised learning is when your data already has labels on it. It's like when you're studying with flashcards. On one side, you have your question. For example, the price of a feature of a house. And then on the other side, you have the price of that feature of the house. Supervised learning, the models basically see so many of these similar flashcards that it learns how to predict the price, the label of a similar question. Now let's flip the coin. Unsupervised machine learning. It's like when you don't have the answer to the questions on your flashcards. Imagine you're presented with a bunch of information and now you have to try and sort it into pattern or similar groupings. It's like when you're given a pile of Lego pieces and you're gonna try and put them into similar categories, but without knowing what the final model is supposed to look like. Next, we're going to go over the most popular algorithms for each of the supervised and unsupervised machine learning. Let's go over some of the most popular algorithms in supervised machine learning. The first one is linear regression. It's when the model outputs continuous numbers when you give it some input features. An example is when you have a scatter plot of house prices and you draw a straight line through it, and that's how you can predict the home prices of similar sizes. This is exactly what Zillow uses linear regressions to predict home prices, which is what they call zestimates. They basically use a bunch of past sales prices, the square footage of your house, and the location of your house, and a few other parameters, and then they predict how much your house costs today. The next one is logistic regression. It's a statistical model which is used to classify your input into different categories. So it's basically yes or no. True, is it true or is it false? Is it spam or is it not spam? It's like a bouncer in a nightclub, right? So when you go in, if you're on the list, you're going to get in, so yes category. And if you're not going to get in, so you're in the no categories. But another example is your Gmail. Gmail uses logistic regression to decide if a certain email goes into your inbox or spam. It looks at email features like the sender reputation, certain words, the links that are in that email, and then it decides if an email is worthy of your inbox or it goes into spam folder. If you're enjoying this video so far, I would really appreciate it if you like it, comment, and also share it. Also, if you haven't subscribed to my channel, please hit that subscribe button. I would be forever grateful to you. It really helps the channel to grow, but also to show this content to others who might find it useful. And in return, I promise I will answer all of your comments. Yes, and also I want to share a few pictures of my recent trip to a beach called Port A in Texas. All right, highly recommend it. So yeah, let's continue, shall we? Next up is decision trees and random forests. Decision trees split data into branches based on some rules like if-else statements. And then random forests are when you take a bunch of decision trees and therefore you can make stronger and more robust, less biased decisions. It's like when you're trying to figure out what to eat for dinner. First question you ask is, do I want something hot or cold? Then if you choose hot, then you're like, well, do I want meat or vegetarian? And then you make a decision. Random forest is like asking the same questions from a group of friends and trying to make a decision based on the majority vote. Your credit card company uses random forest in order to predict and see if a transaction is fraud. They use transaction features like time, location, amount, and if enough trees flag it as suspicious, then they decide and block that transaction. Okay, the last one we're going to cover for supervised algorithms is called neural networks. It's basically modeled after your brain. It is layers of nodes, which are called neurons, like your brain, and they recognize really complex relationships in data. They are widely used because they're good at recognizing patterns in images, speech, recognition. When you see a face, you immediately recognize it. You don't measure the width of the nose or spacing between the eyes. You just kind of know. This is exactly how the neural networks work. They layer simple pattern recognitions and they figure out and solve this complex puzzle. In real world, you can think of Instagram. They use neural networks to figure out what is it that you're looking at, the content that you're posting. Is it a dog? Is it a beach? And then based on that, they figure out what content to show you more of. Now, let me show you exactly how to do this step by step. The goal of this is to predict housing prices based on the number of rooms and neighborhood characteristics using the Boston housing dataset. Step one, this is how you set up your environment. Make sure you have Python installed and then open a terminal or command prompt and install Jupyter and required packages. You can use this command that I have on the screen. Step two, you can go ahead and launch the Jupyter notebook and create a new Python 3 notebook. Step three, you're going to go ahead and import libraries that are needed and load the actual data. Go ahead and use what code snippet I have on the screen. Step four, select the features and target. Feel free to use what I have on the screen, or you can also tweak it as you like. Step five, train the model. And lastly, you can predict and visualize. And that's it. You've just built a model that can predict home prices based on the number of rooms and the economic status of the area. Now, let's move on to unsupervised learning. Here are some of the most common unsupervised algorithms used today. K-means clustering. It's when the model takes data and puts them into clusters based on similar features that it finds in them. Imagine if you're running a coffee shop and you're trying to put your customers into groups. So you want to know who is a only weekend shopper, who is a regular, who is a bargain shopper. And you do this based off of how much money they spend every week, how many times they visit you, what do they order. And therefore, before you start, you don't know who's who, but after you have labels for each person. For example, in real world, Spotify groups people into segments based on what they like. For example, if they like workout music, chill music, 90s hip hop, and then shows the same music to each of those groups. Next one up is PCA, principal component analysis. It's when you remove a lot of the variables in your data so that you can focus on the most important one, which makes it easier to also visualize and analyze the data. Imagine you have a long itinerary for your trip and you compress that into a postcard. So basically, you remove all those details about every meal you eat, every bus you take in between your destinations, and therefore you get to a point where you can really only focus on the highlights of the trip. In real world, genetics research uses PCA to basically remove thousands of gene expression measurements. And so then the scientists can really hone in and figure out the patterns in certain diseases. Right, next one up is, y'all, the name is long, so I have to read it. It is abbreviated for DBSCAN, stands for Density-Based Spatial Clustering of Applications with Noise. Although, don't let the name scare you off. It's fairly easy to understand. This algorithm basically groups the data that are closely packed to each other, and the remaining outliers, it marks them as noise. Imagine you're at a party. This algorithm basically, if it sees a group of people, group of friends standing close to each other chatting, that's like one cluster. And then the person that is on the corner standing alone, that becomes the outlier. In real world, in geospatial analyses, scientists use this algorithm in order to figure out which of the earthquakes are closely coupled with each other and closely located to each other so that they can figure out the real earthquake zones versus removing the background noise. The last one of the algorithms that we're going to cover for unsupervised learning is called autoencoders. It's basically a type of neural network that learns to take the data and basically compress it into a smaller representation and reconstructs it after that, but by preserving what's really important about that data. Imagine you give a 500-page novel to your friend and ask to summarize it for you. They will come back and have a one-page summary, right? It won't cover every detail of the book, but it will have the main plot, the main idea of the book shared with you. In real world, autoencoders are used in banks to detect fraud. They have learned what normal transaction patterns look like, and that's how they can detect anomalies. For example, when there is a huge spike in spending in somebody's credit card, and that's how they detect fraud. And here is how you can do it yourself. The goal here is to group customers based on annual income and spending scores using the K-means clustering. Step 1, we're going to need to install the required libraries. Feel free to use the command that I have on the screen. Step 2, we're going to have to create sample customer data. Again, feel free to go ahead and copy paste this. And step 3, we're going to just go ahead and run the k-means and visualize and see the clusters. There you go. And that's how you group customers without knowing anything about them ahead of time. Imagine a future where all of your software workflows ran themselves. You have an AI agent that acts as your project manager, as your developer, as your tester. They make decisions on their own. They fix bugs and deploy your code. Wait, but what are you going to be doing? You're going to be focusing on true innovation. Yeah, and this is not science fiction. It's called Agentic AI, and it's already here. Hi, I'm Edna. Very good to have you here. I help software professionals grow their skills and become more productive by using AI-powered tools and workflows. I publish videos every week, so make sure to hit that subscribe button so you won't miss out. Agentic AI is a new paradigm shift in automation. They aren't just the usual AI chatbots like ChatGPT. No, they are autonomous entities that they can perceive situations and their surroundings and plan their next move, take action on it, and learn from their surrounding and the feedback. Amjad Masad, the CEO of Replit, recently said at Y Combinator, the value of traditional software is approaching zero. We're entering an age where AI agents will create software on demand, reshape work, and reimagine entire companies. Here's the reason for agentic AI. In the world of engineering, agentic AI means less manual toil and more impact. It doesn't matter whether you're deploying new features or if you're working on running your CI/CD pipeline, doing some triaging some support tickets, it doesn't matter. AI agents can take on any complex multi-step tasks, and the beauty of it is you don't have to babysit them. If you've enjoyed this video so far, I would really appreciate it if you hit that like button, comment, and also share it. And if you haven't subscribed to my channel already, please go ahead and subscribe now. It really helps the channel grow, but also to show this content to others who might find it useful. And in return, there are some more pictures of my trip to the beach. All right, let's continue, shall we? Oh, and make sure you stick around until the end because I'm going to show you how to create your very own AI agent. Here's how an agent actually works. Just like a skilled engineer, it has a reasoning layer. It's basically the brain. It is powered by models like GPT and Claude. It decides based on its surroundings and environment and situation that it's in, what action to take next. The next layer that it has, it's called tools. It's like hands. It thinks and it takes action. And the way it does it is like it uses APIs like Google Calendar, Jira, Slack, CI/CD scripts to accomplish its action. Next, it has memory, just like we do. So it can keep track of the history, the context, and what things it's accomplished so far. And after that, the component that's very important and it keeps and glues all of this together, it's called the orchestration framework. Tools like LangChain, Crew AI, or AutoGen. And lastly, feedback loops. Agents check their own work. They retry, they learn, and if it keeps failing, then they escalate, just like a skilled engineer does. Amjad Masad, the CEO of Replit, explained this really well. Here's what he said. We put all of our resources into agents. Suddenly, things that weren't possible before, like continuous autonomous workflows, became real. We went through a tough layoff, but doubling down on agentic AI brought us from 2.8 million to 150 million in annual revenue. All right, next, I'm gonna walk you through a step-by-step demo to show you how you can create your very own AI agent. Let's get to it, shall we? Let's set up LangChain with a tool calling agent. I'll start with a minimal environment. I have the instructions on the screen, so feel free to just copy paste, follow as directed. All right, step one, we're going to avoid OAuth friction on camera. So, in this demo. So I'll use a mock calendar email, outbox, and you'll still see the agent plan, call tools, and verify success like it would in production. Just, without connecting to Gmail or Google Calendar. Step two, here, now we're going to create the actual agent. The model can decide which tool to call and in which order based on our instructions. This is where the brains meet the hands. The reasoning model orchestrates the tools we gave it, and the executor actually runs them step by step. All right, step three. We're going to ask the agent to schedule sprint planning, invite the team, email the agenda, and then verify that the event exists. Step four, we're going to make the agentic part concrete. I'll purposely ask it to verify after acting. So the agent should call verify event exists and only then summarize. This is like having your junior engineer double check their own work before reporting back. That's it. So just overall, I want to end by saying always make sure you trust your agent, but always verify. Lastly, let's talk about the risks and limitations of AI agents. First one, hallucination. So make sure you don't allow it to push code into production without your supervision. Next one is API costs. Yes, it can add up very quickly because imagine if you're using, OpenAI models or Anthropic models to get their brain running all the time, or these tools like Jira, and you use a lot of API calls, it can easily add up. The third one is security. Make sure that for AI agents, you follow the least privileged permissions. And lastly, over automation. Make sure you don't automate humans completely out of the loop. We need humans to do some supervision and put some guardrails in action so that we can avoid all the risks and limitations of AI agents. Ever wish your software could do more than just following your orders? Imagine if it could learn, adapt, and make decisions for you. Today, we're going to dive into the world of AI agents, the game changer that is impacting how tech teams work, innovate, and grow. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills and become more productive by using AI-powered tools and workflows. Also, stick around because I'm going to show you how to create your very own AI agent in this video. Curious, let me know in the comments if you were to build an AI agent, what would it be? Let's start with the basics. An AI agent is an autonomous software entity that can perceive its environment, make decisions, and also take action to fulfill its goals and duties, all without human intervention. Think of generative AI chatbots like ChatGPT, Claude, Perplexity, Gemini, Grok, etc. as a writer or artist. They have a talent. But AI agents, think of them as assistant or workers that can use that talent to get actual work done, all without human intervention. So as you can see, AI agents aren't just boring robots. After all, mine tried to schedule a meeting with my dog, Caden. Spoiler alert, Caden declined. AI agents are rapidly transforming the way we build, deploy, and scale our intelligent applications. Y Combinator recently mentioned about vertical AI agents, which in some specific industries, they can increase your productivity by 10 times compared to SaaS products. And that causes us to need smaller teams instead of like this huge department of people to get things done. That's the shift we're experiencing. Industry leaders such as Satya, Microsoft's CEO, predict that soon AI agents are going to be the only way we're going to interact with technology. They're going to be doing all kinds of stuff for us, such as completing our tasks, making decisions for us, and even help us with learning. Before I show you how to create an AI agent, I wanted to go over the difference between AI agent and agentic AI. AI agent is basically one that's focused on a specific, well-defined task. You can think of it like a scheduling assistant or coding helper. On the other hand, agentic AI is a collection of AI agents that work together and coordinate to get really complex tasks done and really adapt to your environment. Now, let's go ahead and build an AI agent. We're going to go over an example to create a tutoring agent. And we're going to use one way of creating it, but using ChatGPT, but obviously there's different ways. The first step is to define the goal of your AI agent. In our example, we want the agent to be able to help software professionals learn cloud architecture concepts, guiding users step by step, quizzing them, and adapting explanations based on their responses. Next, we want to design the workflow. In our case, we want the agent to first rate the user, then ask about their experience, present some topics for them, and then starts quizzing them. And the most important part that I really like is that the agent would need to adapt to their quiz answers. So if the user answers correctly, the agent needs to move on to the next question. And if not, the agent needs to give them hints and continue teaching them and sharing them information about that topic. And this is how it's going to help them learn. As I mentioned before, in our case, we're going to use ChatGPT, the web interface. So you can go to the custom instructions as shown here and paste your prompt in there. And obviously, if you're feeling fancy, you can use OpenAI's APIs to create AI agents programmatically. Make sure that the prompt you're creating for the agent focuses on what the agent's role, tone, and adaptability should be like. In our case, this is what the prompt we will be using. You are a friendly, helpful tutor for software professionals learning about cloud architecture. Guide the user step by step, ask questions to check understanding, and adapt your explanations based on their answers. If they struggle, provide hints and examples relevant to enterprise software projects. Don't just give answers, encourage them to explain concepts in their own words. Next step is basically to test your agent. You can start conversation, ask a different cloud related questions, and see how it performs. So refine and then iterate on it. And once you're feeling comfortable and kind of confident about it, go ahead and deploy it. But it doesn't mean that it will stop there, right? You can always come back after deployment and continue refining it as you learn more about it. Now, let's go ahead and see this in action, shall we? Here is a demo of how you can create a tutor AI agent using custom GPTs in ChatGPT. So you go ahead and click on the GPTs from the left menu, and we're going to then click on Create right next to your profile picture. Now we're going to go ahead and copy paste on what would you like to make. We want to make that. So now it's thinking about it, and it's going to go ahead and create it. As you see, it created me a profile picture, pick the name, Cloud Architecture Tutor, and now we can go ahead and, in this preview mode, test it out. So I'm going to say, can you explain what a VPC is? So I'm going to just go ahead and ask, quiz me on what is VPC. Okay, so for number one, answer is D. I'm purposefully choosing the wrong answer to see how it's going to react. So I had asked it to, when the user is being quizzed and gives the wrong answer, to provide a hint, not directly provide the answer. So I'm going to go ahead and refine it and say, okay. So now it went ahead and tweaked this. So I'm going to test the same thing again. Now I'm going to pick, and then I misspelled choice. I'm going to say A. So I, again, purposefully tried to answer the wrong one. It says it's giving me a hint and it's going to ask me to try again, just like I asked it. So now I'm going to give it C because I know that is the correct answer. Perfect. So now see, it's moving on to continue quizzing and helping the user to learn. And that is how you create and refine and test your AI agent. And once you are ready, you can go ahead and click on create, and you can choose like, who do you want to share it with? Only me, or you can share it with and then link with anyone, or on the GP store for to show on ChatGPT. So for now, I just want it to be visible to me and GPT published, and that's your link. See, view, and there you go. There you have it. Here are a few real-world examples. At OpenAI, they have an agent that scans thousands of papers, summarizes them, and sometimes even comes up with its own hypotheses. Another example is at a Y Combinator-backed startup, they are using an AI agent to take care of 80% of support tickets. And that way, the human agents free up to focus on more complex issues. A VP just asked our AI chatbot for Q3 revenue, and it just made up numbers confidently in a board deck. In the next 10 minutes, you'll learn why every AI that you built is probably lying to you. The architecture that Google and Microsoft actually use in production, and how you can build your first RAG system in less than 50 lines of code. Here's what no one told you when GPT-4 dropped. Large language models are great pattern machines, but they suck at remembering your data. Think about it. You spend 3 months training your team on the new deployment process. You document everything in Confluence. And then you go and ask ChatGPT, tell me what is our deployment process? And it goes back and gives you a generic DevOps answer that it has nothing to do with your actual workflow. That's not a bug. It's the limitation of pre-trained models. They are really good at remembering the data that they were trained on up to the cutoff date. They're not going to remember your Q3 roadmap or the conversation you had with your customers last week. And here's the spicy part. When an LLM doesn't know the answer to your question, it doesn't say, I don't know. It hallucinates. It makes up an answer. And this is the billion-dollar problem that RAG solves. RAG stands for Retrieval Augmented Generation. Let's break that down. Retrieval. Fetch the relevant information from the external sources. Augmented. Improve the model's context. And lastly, generation. Produce an answer based on the fetched information and facts. Think of an LLM like a friend who dropped out of college in 2023 and hasn't checked the news since. They're very smart, but they're not aware of the latest news. RAG is that same friend who you hand to a smartphone with access to Google and also your entire company's wiki. Now you ask them a question, they go and fetch the relevant information and provide an answer based on that. And here's the beautiful part. You are not retraining the model on these data. You're not fine-tuning it by using proprietary data. No, you're just telling it, hey, you have access to these relevant documents, so go and fetch an answer for me based on those. Now, let me walk you through the architecture. I promise you it is simpler than you think. The first step is indexing. Imagine you take all of your documents, they could be PDF files, Slack messages, anything, and you break them down into chunks. Each chunk, you can think of it being 500 to 1,000 tokens. Then you take these chunks and convert them into vector embeddings. Embeddings are like coordinates in meaning space. They cluster similar concepts together. For example, the words deployment and release, the vectors for those are going to be very close to each other. Then you take all of these vector embeddings and store them in a vector database, like Pinecone. Second step is the retrieval, basically the searching part. When a user asks a question, you take that and convert it into embeddings with the same model. Then you go ahead and do a similarity search. You basically find the top 3 to 5 embeddings that have similar embeddings as the question. The third step is the augmentation. You basically take those chunks that you found and you inject them into LLM's prompt. You're basically saying, given these relevant documents, you insert the documents here, the chunks, answer this question, you then add the user's question, use only the information provided. Step 4, the last step, is the generation, writing the answer. The LLM basically creates that answer based on the actual data, not hallucination, not outdated data. Stay with me because in 30 seconds, I'm going to show you the numbers on why this isn't optional anymore, and also a demo so you can see it easily. Remember when everyone was saying we all are going to be prompt engineers? Well, the real skill isn't in writing perfect prompts. It's in architecting your AI so that's reliable. And RAG is how your production AI works at scale. Remember GitHub Copilot? That's basically RAG on your codebase. Here's a stat that will wake you up. According to recent benchmarks, RAG systems reduce hallucinations by up to 80% compared to vanilla LLM queries. That's the difference between a tool people trust and a toy people avoid. Okay, real talk. If you're a manager and your team is shipping AI features without RAG, you're actually shipping liability, not value. Let me explain to you with an example so you know exactly why. Imagine your company is tasked with building a customer support chatbot for a SaaS company. Without RAG, customer might say, how do I set up SSO with Okta? With RAG, your system goes and retrieves your documentation on Okta integration, but also the last few support tickets that solved a similar problem. And then AI says, based on our documentation, here's your exact process. And if you're on the enterprise plan, make sure to contact support for custom XAML configuration. See the difference? All right. Let me show you RAG in action without writing even one single line of code. I'm going to be using ChatGPT's custom GPTs, which is basically RAG with a really nice interface. First, I'm creating a new GPT. This is where the magic happens. See the knowledge section? This is our document store, our retrieval system. I'm uploading these 3 internal docs here: a deployment guide, onboarding doc, and API standards. These are the kind of company-specific documents that ChatGPT would never know about. It automatically chunks these, creates embeddings, and stores them in their vector database. All the technical stuff we talked about happening behind the scenes. Now I'm giving it instructions. Things like, you are a helpful assistant for Tech Corp employees, just example. Answer questions based strictly on the uploaded company documents. Always cite which document you're referencing. If information isn't in the document, say so clearly. This is our system prompt, telling it to use retrieval and show it sources. Now I'm adding some starter questions. When do we deploy to production? What's our API authentication method? What benefits start on day 1? These help people know what assistant can answer. All right, let's test it. I'm now asking it, what time do we deploy to production? Let's watch what happens. It searches through the uploaded files, finds the relevant section in the deployment guide, and finally generates an answer. And look, it says, according to the TechCorp deployment guide, production deployments happen Friday at 4 a.m. EST only. It's citing the exact document. This is RAG. It retrieved the relevant chunk from our knowledge base, augmented the prompt with the context, and generated a grounded response. Now watch this. I'm asking, what's our office address? That's definitely not in these 3 PDFs. See? It says it can't find that information in the uploaded documents. No hallucination. It knows its boundaries. I just realized something. Every AI automation that you've ever seen, secretly using a language that you don't understand. And this whole time, it's been hiding in plain sight. In this short video, you're going to discover the one format that makes AI reliable for automation, how to turn chaotic AI into predictable data, and the exact technique that separates the builders from prompt tourists. Okay, so here's what no one tells you when you start building for AI automation. The output is chaos. Imagine you ask ChatGPT to analyze an email for you. One time it gives you the output in bullet point, another time in a paragraph, another time in a table, and sometimes it adds commentary that you didn't even ask for. For brainstorming, this is fine, but for automation, not good. But here's the truth. Automation demands predictability. You need to know where each piece of data lives. You need structure. And right now, the way most people are treating AI is like a creative partner. But in reality, what you need to use it for is like a reliable data machine. That's where JSON comes in. And no, this is not just another fancy tech format. It is a secret language that helps AI stop being unpredictable and start being useful. So what is even JSON? It stands for JavaScript Object Notation. And no, don't let that scare you off. You do not need to know and learn JavaScript. It's just a legacy artifact name that stuck around. Think of it like this. If every app or AI model or system was built by different countries using different languages, JSON is that translator, the universal translator. You basically use it as a common ground to transfer and exchange information without confusion. At its core, JSON is a text-based way to structure data, easy for humans to understand and easy for machines to generate and parse. With that combo, it's like a superpower. Unlike the older formats like XAML that were filled with tags and rules, JSON is very clear, minimal, and efficient, and it structures data in a really logical way that is easy to understand. And here's the kicker. JSON isn't just some niche fancy dev thing. No, it's everywhere. Every API that you ever use, uses JSON. Every modern web app, you guessed it, uses JSON. Every AI platform's APIs, uses JSON. So basically, JSON is the backbone of the entire internet. And listen, in about 4 minutes, I'm going to show you how to take a messy customer email and turn it into a perfect automated task system by using JSON and AI. Also, while you're at it, hit that like button and share this video with one of your engineer friends. So, why is this important for your career? Why is this simple text format the difference between you dabbling with AI and creating actual production systems? One word: structure. JSON has become the lingo of the modern software. For example, when your AI needs to send data to the CRM, or when you need to retrieve and get data from Slack, or when two systems need to coordinate with each other, you use JSON. It's basically the glue that keeps all of this ecosystem together. Here is an analogy. Imagine two people trying to coordinate. Person A reads an email, person B needs to update a spreadsheet based on that email. If person A just yells across the room a summary of what the email is, person B is going to do a messy job updating that spreadsheet. But if person A writes it on a note card with clear labels, for example, sender, action items, body, with their values, then person B would know exactly what to do. That note card is JSON. Bill Gates once said, "The first rule of any technology used in a business is that automation applied to an efficient operation will magnify the efficiency. But automation applied to messy, unstructured data, that just magnifies the chaos." JSON is how you eliminate the chaos. If you're still watching, you're above average. Comment level up below so I know who our builders are. All right, let's decode this thing. In order to be able to use JSON, you need to be able to read it. And I have good news for you. It's stupid simple once you see the structure. JSON is built on one core concept: key pair values. Think of it like a dictionary. The word that you look up is key, and the description that you get for it from the dictionary is the value. In JSON, the key is a text in quotes, followed by colon, and then the value. And values can be in a few different types. Strings, that is text in quotes, like hello world. Could be numbers, so no quotes, like 30 or 99.5. It could be in Boolean type, so just true or false. And it could be null, represents basically nothing, writes as null. Now, here's where it gets powerful. You combine and group these key value pairs into two main structures: objects and arrays. Objects are a collection of key value pairs wrapped in curly braces. Think of an object as a contact card. It holds labeled information about one thing. Arrays are ordered lists wrapped in square brackets. Think shopping list, items in order. The real magic, you can nest these objects inside objects, arrays inside objects. This lets you represent even the most complex data with perfect clarity. Clean and powerful. Easy for humans to understand, easy for machines to process. That's JSON for you. Let me show you an example. A real use case: automating customer support emails. Here's the problem. Imagine you're running an online business. Customer emails are coming all day long. Right now, you have somebody manually reads every email, figures out what it's about, and then creates a task to send it to the right team. Frankly, that's boring and error prone and inefficient. So, with the JSON solution, we are going to use AI to automate this process. Here's the workflow. New email arrives, then automation tool grabs that email body, sends it to AI with specific instructions, then AI returns structured JSON, and automation lastly creates a task in Trello or Asana automatically. All right, let me show you how this works in action. I'm going to demo this to you in Jupyter Notebook with OpenAI's APIs, all free tiers. Starting with a clean notebook, first we'll install the OpenAI library. This gives us access to the ChatGPT models. It takes about 10 seconds. Now we import the library and set up our client. The client handles all API communication. You'll need an API key, obviously, from OpenAI, and they give free credits when you first sign up. Next, let's create a sample customer email so we can use it for testing. This is very unstructured input, right? Just a regular customer email. All right, now here's where the magic happens. We craft a prompt that demands JSON output. You can feel free to use this prompt I've already created. Notice we're not asking politely. We're giving strict instructions, exact keys, limited categories. This is how you control AI output. And now we send it to GPT-5 and we will wait for the response. As you see, we get a very structured response back. No guessing, no parsing paragraphs, just clean and usable data. Well, now we can parse this and use it in automation. Your workflow tool can now grab these values and create tasks, update databases and notifications, whatever you need. Here are 5 cloud architecture concepts that every modern app needs. And why skipping them? It's like building a house on a trampoline. Let's break down the cloud so even your grandma could scale an app. Here's what you're gonna learn. Hosting a website for free on AWS S3. How to automate with code. How to scale smoothly. Choosing the right cloud. And ending with how to master storage. Hi, I'm Edna. Welcome to my channel. I help software professionals grow their skills and become more productive by using AI-powered tools and workflows. Let's talk cloud providers. There are 3 big players out there: AWS, Azure, and Google Cloud. AWS is known for having many services and tools and a great community support. It's like the Swiss Army knife of the cloud world. Azure is great if you're using Microsoft tools. It basically hooks up into anything for Microsoft. And Google Cloud is really good for AI and ML world. It dominates it because of things like TPUs and Vertex AI. But most companies actually use more than one of these products. For example, they could be using AWS for API and GCP for Google Analytics and Azure for their compliance. Now, let me show you how to host your website for free on AWS S3. All it takes is 5 quick steps. Create a bucket, upload your site files, turn on static hosting, allow public access, and grab your website link. No servers, no configs, just pure cloud magic. All right, step 1. We're gonna go to S3 and create a bucket. This is your website's cloud home. Step 2. We're going to upload our index.html file and any other assets that we like. Step 3, here under properties, I'm going to enable static website hosting. And after that, we just need to go to permissions and set public read access so the whole world can see our website. Now, copy the website URL and open it. Voila, your site is live. That's it. Free hosting, zero hassle. Quick cloud reality check. That 3 cents per gigabyte that you might have noticed sounds cheap, right? Until you forget to turn off a test environment. Cloud bills don't explode. They quietly grow. Always set budgets, alerts are very important, and delete those old buckets. I promise you, future you will thank you very much. If you've enjoyed this video so far, I would really appreciate it if you hit that like button, comment, and share it. Also, if you haven't subscribed already, hit that subscribe button. It really helps the channel grow, but also to show this content to others who might find it useful. And in return, here is a cute picture of my dog, Kaden. All right, let's continue, shall we? Let's get to the core concepts. The first one is infra as code. Why keep clicking around menus if you can write it once and use it forever? Terraform lets you do that. It lets you define your infra and write it in code. Imagine deploying 5 web servers, their firewall rules, and also a database, all with a simple file. Yeah, that is infra as code for you. The next one is Virtual Private Cloud, VPC. It's like having your own apartment in the cloud. You set up walls, you lock the door, you control who gets in and out of the apartment. You can think of the public subnet like that front room where it's open to guests, and your database, it's hidden in the back with no street access. Now let's talk about regions and availability zones. The cloud is basically split into regions. East US, for example, West US, Tokyo, and each region has multiple zones, basically separate data centers. Why? Because if one goes down, the others continue working. That is basically your disaster recovery without drama. For example, when AWS Virginia zone went down, services like Netflix and Zoom continued working because they were multi zoned. Next one is elastic load balancing and autoscaling. Imagine a restaurant. The host is the load balancer. They basically direct guests to their tables. If there are more guests coming, they open more tables. And if there are fewer guests, then they close a few tables. That's exactly what happens when your app is able to scale. Basically, services like AWS lets your app keep its performance, but also saves you money when the traffic is low. And lastly, different cloud storage types. S3 in the world of AWS is like your attic. You store files and you forget it. EBS is like your SSD card. It's fast, local, and responsive. And EFS, it's like your shared drive among machines. It's great for collaboration. In our demo, we used S3 because we were saving static files. But normally for apps and databases, EBS is used for really fast and quick access. If you enjoyed this video, I would really appreciate it if you hit that like button, comment, and share it. If you haven't subscribed yet, click that subscribe button as well. I would really appreciate it because it will help the channel grow, but also to show this content to others who may find it useful. And now I leave you with a joke because life is too short not to laugh. Why did the cloud application break up with the data center? Because it needed more space. Well, and a higher uptime.